Hi, welcome you all on Physics Addhyan. And in the previous lecture, we have just started the topic friction and we have studied about the static friction. So, in the today's lecture, we will be dealing with kinetic friction. As we have discussed in the static friction, that acts between the surfaces where there is no relative motion. So, in kinetic friction, it acts between the surfaces between the surfaces whose relative velocity relative velocity is non-zero. Okay, so it acts between the surfaces whose relative velocity is non-zero. What I mean is, suppose there is a surface, okay, and there is a one block on it which is moving with velocity v, okay, and this is not smooth, so this is not a smooth surface, so it means there is a friction. So if I write the friction, then the frictional force Fs will be acting along this direction, or let me change it. The frictional force Fs will be acting along this direction if the if the block or the body is moving in the positive v direction. So there will be two more forces, that is mg, that is the gravitational force downward, and the normal force n acting on the block. Okay, so this is the situation. So the kinetic friction Fk, force of kinetic friction, is equal to mu k times n, where mu k is a constant and that is called the coefficient of the kinetic friction. You must remember in static friction it was mu s, so mu k is always less than mu s. So that is one relation between mu k and mu s, that mu k is less than mu k. So there are one more thing in the problem. If mu s and mu k are not given separately, not given separately, suppose there is a problem and these two quantities are not given separately, then you take it as, you can take mu s is equal to mu k is some constant mu. Okay, so you can assume this if in problems that is not given. So to make a stationary object, so let's discuss one more thing. Okay, so to make a, we are just building up a small concept so that we can do some problems. So to make a stationary object move, that is the force applied is parallel to contact surface, contact surface must be greater than, must be greater than, that is the Fs maximum. Okay, so if you wish to block move, then you have to apply the force that is parallel to the contact surface, that should be the greater than maximum static force. So suppose there is a maximum static force of, let's say, 10 Newton, then you have to apply the opposite force of the parallel force, more than 10 Newton, so that the black should, or the block should move. Okay, so let's do example here on this concept. So let me write the problem. So this is your problem where we have seen that there is a block of mass m, a force F is applied, and on a block on the surface, that is with friction. Okay, so the question is, will the block move or not? So let's draw the free body diagram of this block m. So a force F is applied in this direction, and there will be a frictional force. Let's talk frictional force later. So there will be a mg gravitational downward force, and there will be a normal m, and if the block moves, then there will be a the block will either move or not, but there will be a frictional force because the surface is not smooth. So let's call it as Fs. So your N is equal to mg. That's the first equation. And from the second equation, you can get that frictional force is mu times the normal force. That is mu times the mg. So mu is your 0.5, m is your 20, and let's take g is equal to 10. So this will become your 100 Newton. So if frictional force is, so this is similar as you apply 70 Newton this way and there is a frictional force of 100 Newton. So this block will not move this side because the force that will change the state of the body will be by the 70 Newton. Okay. So to change the state of the block from rest to motion, you have to apply the force. So because 70 Newton is greater than 70 Newton, it means frictional force is greater than F applied. Okay, so block will not move. So block will not move. So this was the first problem of this concept. Let's see a few more problems. So now let us discuss some general problems that has been asked in many of the exams, and their results can be applied in many physical situations. So let us discuss such results. So now I am going to discuss problems on frictional force. Frictional force. Okay, so this is the main topic, problems on frictional force. So let's discuss first problem, that is, consider there is a block that is sliding on rough surface. On rough surface. So this is the first problem that we are going to deal. So suppose there is a some surface on which there is a block of mass m. So and there is a velocity which is it moving v. So let us suppose that this direction is your positive direction of motion. So the if you write the forces of this block, so there will be a mg downward force, there will be a normal n force, there will be a frictional force fs. So if you write your f, the total force is equal to mass time acceleration. Total force is minus fs times mass times acceleration, then minus mu times the normal force is equal to ma. This was the equation of motion of this block because there was no other force, only frictional force was there. So minus mu mg is equal to ma. This implies that a is equal to minus of mu g. So the acceleration of this block is minus times mu g. So for a person walking on a surface when friction is static, then the maximum acceleration will be mu times g. Okay, so that was the conclusion from here. Whether it is positive or negative, it just depends the sign. So the maximum acceleration is mu times g. So this was the very first problem, that is a block that is sliding on a rough surface. So acceleration is minus mu times g. So that is for a person that is walking on a surface. If the friction is static, then the maximum acceleration will be mu times g. So this was the plane surface. So let's move to a second problem where there is not a plane. If there is a block sliding on a surface that has some wedge shaped. So wedge block sliding on a surface. Okay, so there can be two situations. So let us consider both the situations one by one. Okay, so let me draw the picture first. So okay, so that for one. So let me draw for the second one. Okay, so consider these two situations where, let's say, the angle between this wedge is theta. Okay, both are the identical wedges. So there is a block of mass m. So I have drawn two because there can be two type of motion. First, the block can move downward to the hill downward direction, or the block can move the upward direction. Okay, so we have to consider both the cases. So let us do one by one. So this is your first case, this is your second case. So let's discuss the first case one. So first, if we wish to write the Newton's equation of motion, then we have to write its free body diagram and the forces acting on it. So there will be a normal mg force acting downwards. Okay, and there will be a normal force acting in this direction, and the block is moving downwards, so the frictional force will be acting in this direction, that is frictional force. So if we decompose this, so we will get a component of mg in this direction, this angle will be theta, then you will get mg cos theta in this direction, and this will be mg of sine theta. Okay, so the very first equation which you can write is mg cos theta is equal to normal, because there is no motion in this direction. If I consider this direction as plus x direction, if I consider this direction to be plus x direction, then the second thing, m a, because it is moving downward, is the net acceleration, that is mg sine theta minus of fs. So that is a net force acting on this block in the x direction. So you can write m times a is equal to mg sine theta, frictional force is minus mu times the normal. If I replace the normal by this mg cos theta, then you will get, I will replace this by mg of cos theta. So this mass will cancel from each other. So a will be your g, you can take common. So this is sine theta, minus of mu cos theta. Okay, so this is the acceleration of the block when it is moving downward direction. And let's study for the similar case, that is the second one. So in the second one, the mg will be acting in the same way as it was before, but the block is moving upward, so the frictional force will be acting in this direction, in fs. So now when we decompose the mg in two vertical directions, that is mg of cos theta, and here will be mg of sine theta, and the block is moving in the upward direction. Okay, so the very first equation you can write, and obviously there will be a normal force n. The very first equation which you can write is n is equal to mu times, n is equal to your mg of cos theta, and the second thing, your frictional force is mu times n, that is mu times mg of cos theta. If you write the acceleration of the motion, because the velocity is this direction, then net acceleration in the direction of motion is, net force is equal to minus fs plus mg of sine theta. If you put that, then acceleration will become minus g, you just substitute that, minus g plus mu of cos theta. Okay, so this will be the second one, acceleration. So see, acceleration, whether the block is, if the block is going downward, then the acceleration will be given by this equation number 1. If the block is moving upward direction, then the acceleration is given by the block 2. Okay, so this was the situation. So remember, both the accelerations are not same, first thing, and second, if there is any situation where you find these types of motion, then you can directly use this equation. So the acceleration is, let me write it as acceleration down this as acceleration up. Okay, so you should remember these formulas while your examination. So let's move further. So let us discuss one more problem here. So this is a question. So the question is following. So suppose there is one wall and there is a block. Its mass is m, and there is a force F is applied on this block, and there is a coefficient of friction that is, let's say it is 0.5. Then you have to comment on this statement whether the block will move or not. Move or not. So you have to compare these two cases when mass is equal to 10 kilogram and mass is equal to 3 kilogram. And the second thing, your force is given to be 100 Newton. Okay, so these are the situations. So again, if you draw the free body diagram, then there will be a force mg acting downward direction. Okay, if it moves in the downward, then there will be a frictional force Fs in the downward direction. So you know your Fs is mu times n normal force, and the normal force will be the force that is this. Because if you apply a force on a block here, then the always apply a force on the this block m. So it will be the same as you applied. So mu is 0.5 into 100, that is your 50 Newton. So 50, so consider this situation, 50 Newton is applied in this direction, and this force F external will depend upon mg. So if we consider these two cases, let's case first, case 1, where m is equal to 10 kilogram. So if m is equal to 10 kilogram, your F external will be 10 into g, let's say 10, that is 100 Newton. So the force applied, okay, force applied that is parallel to the surface is greater than Fs maximum value, because Fs maximum value here is 50 Newton. So in this condition, block will move. If we consider the second case, let's call the second case when mass is equal to 3 kilogram, then you can see the F external is 3 into 10 is equal to 30 Newton. So the force is 30 Newton. In this case, the force that you applied, which is parallel to surface, is less than the frictional force, the maximum value. So block will not move in this condition. So it depends upon the what mass is. So you have to check whether that satisfies these two conditions or not. The force that is applied to parallel of the surface, if it is greater than the maximum frictional force, then it will move, otherwise it will not move. Okay, so that was the one problem that I wish to discuss. Let's move further. So now let's discuss this problem. So this is what minimum force is required to move the object. Okay, so this is simple. There is a horizontal plane which have a static coefficient of mu. Okay, so it has a static or kinetic friction coefficient mu and mass m. So what is the minimum force that is required to move this object? So one can easily do this problem by considering, okay, there is a mass m, let I apply a force m, and there will be two forces, that is mg downward gravitational force and normal n, and you can simply write that fs maximum, if it is equal to mu times n, then it will move. Okay, that is your F applied, so that is mu mg. So if you do this, you are obviously wrong, because this is not the force that is required to move the object. Here it is asked minimum force. What should be the minimum force to move this object? So this is the case 1 where if the horizontal force is applied, then this is 2. But there is no restriction on the direction on which you apply the force. So let us discuss one another case. Okay, let us discuss the case 2. Let's say there is a the similar problem, same question. There is a horizontal surface which have some static or kinetic friction coefficient, a block on it, and let's say a force is applied at an angle theta, a force F that is an applied angle from an angle theta with the horizontal. Okay, so that was the situation. Let's take at any arbitrary angle theta. So there will be a motion of this block. If it happens, then obviously there are two forces, normal and upward, and gravitational force mg downward, and there will be a frictional force Fs acting in this way. So if I break these components, so my this component of force will be F of cos theta, and this component of force will be F of sine theta. So if I draw the free body diagram, so this is mg, this is F, sorry, n, this is n plus F of sine theta. Okay, so if I write the normal from here, so normal plus F of sine theta is equal to mg. So here the normal force is equal to mg minus of F of sine theta. So see, normal force is dependent upon the force you applied and the direction at which you apply. Okay, in this case it was theta was 0, then sine 0 was basically your 0, so your normal was mg, which should not be the case. Okay, so the frictional force maximum value is equal to mu times n, that is mu times mg minus F of sine theta. So remember this. Okay, now do some further calculation of equation of motion. So this was the thing. Now the block will move if Fs, this frictional force, the maximum frictional force value is equal to F of cos theta. If this happens, then the block will move. So see, there is a block F cos theta acting in this direction, and Fs is acting. If this is equal to or greater than Fs maximum value of Fx maximum, then it will move. So this is the condition which I just wrote here. So Fs is mu mg minus F sine theta is equal to F of cos theta. So if you simplify this, what one will get it, take F that side, so F will be mg, that is mu mg divided by cos theta plus mu of sine theta. Okay, so that is the force that is required to move at an arbitrary angle theta. Still, this force is depends upon theta, depends upon theta. So it is not the minimum force. Minimum force. So if you want to find the minimum force from this expression, you have to use the concept of maxima and minima. So let's write it here again. Let me write it here very clearly. Your force becomes mu mg by cos theta plus mu sin theta. So remember, if you wish to find the maximum value of force, you have to find minimum value of cos theta plus mu sin theta, its minimum value. So because if this function is minimum, this force F will automatically be maximum. So F will be sorry, you have to find force, the minimum force, then this function should be maximum. So you have to maximize this function cos theta plus mu sin theta so that you can get the minimum force. Okay, so what you have to do, just do the derivative d by d theta of this function cos theta plus mu sin theta. Put this derivative to equal to 0, you will get minus sin theta plus mu cos theta is equal to 0, implies that mu is equal to tan theta. So if mu is equal to tan theta in this problem, so put theta is equal to tan inverse of mu, you will get the answer. So this is the theta, if say this is mu, this is 1, so this is 1 plus mu square. So you can find sine theta from here, that is mu by under root 1 plus mu square. If you do the cos theta, that is 1 by under root of 1 plus mu square, then just substitute this value. So f will be m mu g by cos theta is 1 by under root of 1 plus mu square, plus there is already a mu, and mu by 1 plus mu square ki power half. So 1 plus mu square by 1 plus mu square under root, so this is mu times, so the force, minimum force is mu times mg by under root of 1 plus mu square if you do this. Okay, so this is the minimum force that is required to move that block at an angle that is theta, which is nothing but tan inverse mu. So this is minimum force which you will get at the particular angle theta, that is tan inverse of mu. Okay, so if you apply the force at this particular angle, then you have to minimum apply this much of force to get that object move. So now we just did a problem. Let's move to another theory, or one more important conclusion, or one more important topic. So let me write the topic here. So it is a concept. So the next concept is two blocks problems. Two block problems. So now we are going to discuss this. Two blocks problems means suppose there are two blocks which are, let's say these are mass m1 and m2, that and they are hanging one to each other, or they are put on another one on each other. So you have to, suppose the question arc, you have to find the maximum acceleration so that block can move each other. What is the maximum force so that uh, both the blocks move each other? So these types of question can be asked. What is the maximum velocity of these two blocks? So we are going to discuss this. Okay, so let's start by solving a problem. So basically I used to do this concept by dealing with problems. So first question is, what is maximum acceleration so that block moves together? Okay, so this is the question, and the problem is like this. So suppose there is some surface, and there is a one block m2, let's say is mass. There is another block of mass m1 on that, and this surface you can consider as a smooth surface, and the force F is applied on the upper block, remember. So this is given in the problem. F is applied on upper block, first case. Okay, and there is a coefficient of friction, that is mu. So you have to find, so, and the condition is both blocks should move together. Okay, so what concept we are going to use is this. So acceleration of m2 has limit. Why there is a limit? Because it moves. I am applying a force on F on m1. So why does the block m2 moves? Because of the friction. So acceleration of m2 has a limit because it moves due to Fs, and that is nothing but static friction. So block m2 will move due to the static friction that is created between the F. So the situation is like similar. This is a block m2, and there is a force Fs acting on it, so that is moving in the forward direction. So what happens to m1? So acceleration is limited by m2. So acceleration is Fs by m2, because Fs is the total force that is acting on M2 is Fs. So this is just Newton's equation of motion. So if we find at a maximum acceleration, because we have to find the maximum acceleration, so maximum acceleration is maximum force by M2. So we just started with this concept that acceleration of M2 has limit because it moves due to Fs, static friction, and acceleration of M2 is Fs by m, because Fs is the total force that is acting on M2. So maximum acceleration is maximum force upon M2. So the maximum force, uh, the frictional force will be, let's look on this block. So if M2 has a friction in forward direction, then M1 has a friction Fs, let's say on surface 1, this is on surface 2. So Fs1, and there will be a force F in this direction, there will be a normal in this direction. So this normal is related with this Fs1. Okay, so and this normal, this force and this force are equal. So maximum value of this is equal to maximum value of this is equal to maximum value of n. So from this contact, for this contact, the normal force is m1g. So this is mu m1g by m2. So the maximum acceleration is this much, a m1g by m2. So this was the case when we applied the force on the upper block. Okay, let's say what happens when we apply the force on the lower block similarly. So let's do here. So okay, so on, if we apply the force on, if the force F is applied on lower block, then what is the maximum acceleration? So the picture will be look like this. This is M2, this is M1, and this force is applied F here, and this is your smooth surface. Okay, now using the same concept which we have just written earlier, if you apply that, now the acceleration is limited by m1. So the acceleration is limited by mass m1 because it is moving by Fs, that is the frictional force. So frictional force is m1 times a acceleration. It means a is equal to Fs by m1. Then the maximum acceleration is Fs maximum by m1, and we know Fs maximum as mu m1g by m1. It is mu times g. So the x maximum acceleration, mm, that is a maximum acceleration is mu times g. So that is the second case. Okay, so now let us just conclude these two. So in the case first, when F was on upper block, you get the maximum acceleration as mu m1g by m2, and we discussed the similar case 2 where the force is in a lower block. You get the maximum acceleration as mu g. So these were the two cases. So if the problem asks that whether the two blocks will move forward in with the same acceleration or not, then have what can you do, or what you have to do, or at least there is a one trick to do this without wasting your time. So that is, let's do state this problem. If two blocks are given, similar situation which we have just discussed here, then you will find this quantity. Find a is equal to f by m1 plus m1. Just do it. Whatever there is a lower block, upper block, just do that. So if a, this quantity, if a is less than a maximum, then block then blocks moving together with acceleration a. Okay, and if a is greater than a maximum, then blocks are not moving together. So you can just uh, simplify or just you can do a quick check whether the blocks are moving together or not. If the blocks are not moving together, then you have to separately again calculate acceleration. So you can do just a quick check whether this acceleration, that is f by m1 plus m2, that is the acceleration of both blocks. So if a is less than or less than a maximum, then the blocks are moving together with the acceleration this a. If a is greater than then they are not moving with the same acceleration, then you have to calculate them separately. Okay, so that was the from this. So I think this can be enough, or this is enough theory for your frictional force part. If you wish to do some problems, then you can always try this. So using these types of concept or these types of similar tricks, you can do any type of problem from frictional forces. So till now we have not discussed the projectile motion part. So I will be covering in the next lecture will be the projectile motion, and there are some problems that has been asked in TFR and just examination, and that are the mixture of projectile motion and circular motion. We will also have a look on those problems, so, and those are really important problems to do. And then we will be covering our the first unit, that is the Newton's laws of motion, by using by just doing the next part, that is the projectile motion and some problems on projectile and circular motion. Then we are done with Newton's laws of motion, and after that we will start with I think hopefully we will start with work energy and theorem, like work energy and power, and then we will start some uh, that is Kepler's law, that is central forces, and then we will move on to rigid body dynamics. So I think for Newton's laws of motion, the only topic which is left is that is your projectile motion. So we will be covering in the next lecture. So if you have not subscribed the channel, do subscribe the channel and share it to your friends who are preparing for these types of examinations, or this can be also useful in your semester examinations or in your university examination. I'm not sure about the university examination because that is very much based on the previous year paper. All universities have the same thing. So if you are really interested or really want to do core science, then you are welcome and watch these videos and share also to your friends. So thank you, subscribe the channel, have a good day.